Hello, my name is Robert Whitney. This presentation is a brief introduction to Riverhawk's torque blocker. What is a torque blocker? Essentially, the torque blocker is protection for equipment against extreme torque events. The torque blocker protects by disconnecting machinery shafts when there is a torque transient. Makes it a mechanical fuse. The torque blocker releases very quickly, usually in less than a thousandth of a second. This provides maximum protection. Torque blocker locations? Well, it can be shaft mounted or mounted within a coupling spacer. The image at the left shows a spacer mounted version. Torque blockers can be made to match virtually any coupling type. Inside, there are internal bearings within the unit which allow for safe coast down after an event. Here is a section view of torque blocker internals. First, it's important to understand that the torque blocker exists in one of two possible states. First is the activated state, where torque and speed are seamlessly transmitted between machinery shafts and as a solid connection. And in the release state, where machinery shafts are free to rotate independent of each other. This view shows the torque blocker in the activated condition. The red arrows at the top show the torque path when activated. It's important to know that torque and speed can go in either direction through the torque blocker, and protection is bidirectional as well. For discussion purposes, let's assume that the driver is on the left. Torque enters the left flange, travels radially down to the sleeve, runs along the sleeve, and then crosses inwardly to the stub shaft. The torque then travels along the stub shaft, up the right flange, and into the load machine. The critical connection within the torque blocker is the fit between the sleeve ID and the stub OD. When activated, the sleeve is firmly pressed against the stub OD to generate a precise amount of friction that controls how much torque can be transmitted. When deactivated, the sleeve springs to its free state, where a gap exists between the sleeve and the stub surfaces, making them able to rotate independently. The tight grip that is so important to the torque blocker's ability to transmit torque comes from the hydraulic clamp, which is depicted here as three parts: the HTC piston, the HTC cylinder, and the HTC collet. This assembly is based on the Riverhawk hydraulic torque coupler product, which already is in existence and is established as a powerful way to make shaft connections. Two key subassemblies are the fuse assembly and the coast down bearings. These are additional assemblies. The fuse assembly consists of a series of radially located fuse pins and the feedback ring. When the unit is activated, the fuse pins are firmly held between the tapers of the piston and cylinder by inwardly facing teeth within the feedback ring. As long as the fuse pins are held in place, the HTC retains torque capacity of the torque blocker. When a high torque occurs, the feedback ring rotates slightly relative to the HTC, causing the teeth to disengage with the pins, freeing them to slide out radially and allow the HTC halves to unload and release torque. Reset is accomplished by applying hydraulic pressure to the cylinder cavity, usually between 3,000 to 5,000 psi, and repositioning the fuse pins to the set position. The result is a hydraulically activated and mechanically retained assembly that is carefully calibrated to release only when an overload occurs. Sometimes a physical demonstration can answer a host of questions. So here is a handheld model of a fuse mechanism. We can partially take it apart to see the components. First, I'll drop the pin down in. Let me take the slider off, and you can see a couple of very important parts. You can see the top of the fuse pen, the shiny part, and you see these teeth. And then you can also see how the fuse pin sits down inside the tapers. I'll slide it back and forth a little bit so you can see how it slides in and out. Okay. We can take that fuse pin out. There is the fuse pin. You can see the tapered sides, the top flank. Here's a real fuse pin, similar item. This is out of a unit that's rated for 4.5 million inch-pounds. Similar design, a little more articulation on the top. Okay, so now we'll drop the pin back into the fuse mechanism. And you can see how, if I squeeze it, maybe you can see, let me get a little closer here. See how it slides up and down when I squeeze it? Okay. Next, we're going to set the fuse pen by putting the slider back in and sliding the tooth over the fuse pin. So this is just like setting the unit. Slide that like so. Okay, now it's a solid assembly. You can shake it, move it around. This is the way the torque blocker is, the fuse mechanism in a torque blocker that's set. So now what we're going to do is we're going to fuse this off. So I'll apply pressure to the clamp pads, and I'll mimic the sliding of the feedback ring by sliding the slider. That is how the fuse mechanism in a torque blocker works. Here are a few of the benefits of the Riverhawk torque blocker design. Torque blocker is designed and built to tolerate extreme torque events. There are no sacrificial pins or plugs to maintain or replace. Torque blocker is inherently resistant to high bending or high dynamic torque loads. There is no need to retain or seal high pressure oil within the torque blocker during operation. Several release settings can be supplied, and each unit is full load calibrated on a torque stand that is equipped with NIST traceable sensors. Thank you for watching our introduction to Riverhawk's torque blocker. You can request a quote or just get more information about torque blocker or any of our torque transmission and torque control devices at the addresses listed on this slide. Best regards and have a nice day.